In this lesson, we're going to take a look at how to apply heat capacity. So in this scenario, we're going to heat up some water and we're going to go from 20 degrees up to 100 degrees. But of course, this process depends on how much water there is. So as we take a look at what these parameters are, we'll start off with a modest amount of water. Let's say that M is equal to 150 grams. And then based on the lookup table, we know that the heat capacity for water is 4,186 joules per kilogram degree C. And delta T, of course, is going to be a difference between what we have in the end and what we have in the beginning. So we want to make sure that these units match up, and I have grams and kilograms. So that's a mismatch. So I'm going to go ahead and divide this by 1,000 so I have it in kilograms. So now when I put everything together, we want to just, I'm going to put in units for right now, just so that we can make sure that the units are going to cancel correctly. So 100 degrees minus 20 degrees C. Now, one of the questions, of course, is when we consider the difference between the low setting and the high setting, is how much time it's going to take in order to deliver this heat. A joule is actually a really small unit of energy, so that's why we get a pretty big number. So if we were concerned about this, we might be thinking about time. So we know that this setting is going to be faster, and this setting is going to be slower. So mathematically, how do we deal with that? And the answer is about power. Power is equal to the rate at which energy is delivered. So this would be Q over T. So let's install a power. Let's suppose that this faster setting might be a pretty high power, maybe 500 watts. And the slower setting might be something much less, like say 200 watts. So let's take a look at time. Time at 200 watts and time at 500 watts. And let's just take a look. So that means that we're going to have power times time is going to be equal to 50,232. And then we're going to divide this by whatever the power setting is. So 50,000 divided by 200 compared to 50,000 divided by 500. And let's just see how things come out. So this gives us 251 seconds. And then this is only 100 seconds. So about a minute and a half and about a little over 4 minutes.